Ranger 2, prepare to detach.
What? No! No! Cooper!
3.
Cooper, what are you doing?
Newton's third law. You gotta leave something behind.
Hello, S. This question's from OxfAQA, year 13. So an object is suspended from a spring of stiffness K. Extension of the spring is delta L. The object is displaced vertically, so you're looking at your formula. T is 2 pi square root m over K, so it's a mass spring system. Let me just change this pen. Okay, so the procedure is repeated using the same object and a spring with stiffness 2K, and the values of delta L and F are different for this new spring. So F. So they're talking about F. So F is 1 over T, so it's 1 over 2 pi square root K over M. So which quantity doubles when the second spring of stiffness 2K is used? So when it says which quantity is doubled, they're saying which one is now equal to 2 times the old quantity. Okay. So now the question is when you go from K to 2K, well, look what they do. And they've got F times delta L in every one of these. Now you're probably looking around in your textbooks or your specifications. You're thinking, what formula has F delta L? What is that equal to? It's not equal to anything because the only formula that's connected to is Hooke's law, which is F equals K delta L. So K is F over delta L. There's no F times delta L. So they're not asking for you to find a formula. They're asking what is the new F and what is the new delta L and which sort of combination would cause you to get 2. Okay, so you'll see what I mean. So if you go 2K, well, what does that do to your F value? Well, what do you know about F? If you look at the formula here, F is proportional to root K. So if you go to 2K, F is now proportional to root 2K. So F is proportional to root K. Okay, so, or if I was to rewrite that, actually, no, I'll leave it. Root K. So the new F dash, let's call it F dash is proportional to root to the old F. Now let's do the other one. Well, what do you know about delta L? Well, if you double the spring constant, you're going to halve the extension for the same force because F equals Kx, okay, or X is F over K. So double the K, that now becomes delta L over 2, okay, or the new L, new delta L, sorry. So what does that mean? Well, when you put them together, F dash delta L dash, you've actually got root 2 from the because of the spring constant, and you've got over 2 because of the delta L times by F delta L. So that's what all they're asking. What is the new F and the new delta L when you put them together? Now they're asking, well, which combination is going to give you a double? It's going to give you 2 times F times delta L. Well, if you actually did root 2 on your calculator divided by 2, that's actually 0.71 times the old one. Okay, F delta L or F dash delta L dash. So that means it can't be this one. That's not going to give you 2. That's going to give you 0.71. It's not going to be D because if you do that squared, you get a half. Okay, that will be equal to 0.5. Okay, so it can't be that. Let's do the top one. So if you did 1 over 0.71, because F delta L, the new one is 0.71. So if you did 1 divided by 0.71 equals, and then squared it, because this whole thing is squared, that gives you 1.98. So yeah, so it could be, it's A. Okay, so which quantity doubles when you use 2K? When it's 2K, F delta L is 0.71 times bigger than the old F delta L. So when you do 1 over that and square it, you'll get that answer. So it's a tricky question in the sense that you're looking for a formula with F delta L. That's not what they're asking. They're asking, hey, what is the new F and the new delta L? And when you combine them, what do you need to do to it to be able to get equals to? Okay.